This is a video talking about some strategies for simplifying expressions using trig identities or verifying a trig identity using other trig identities. So some strategies based on what we've learned so far. I have 4 strategies for you, and I recognize that this can be, that simplifying or verifying trig identities can be hard because it's not immediately apparent from looking at the problem what the appropriate path is, but having some strategies at your disposal will be helpful. So the first thing that I would say is look for if you have a squared trig function. Because if you have that, then you want to think Pythagorean identities. So it's a good idea, at least for now, when you get to an assessment, to write down the Pythagorean identities, just so you can glance at them. And they are the following: sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta. And the third one is 1 plus cotangent squared theta equals cosecant squared theta. And remember, these are all derived from the Pythagorean relationship between x, y, and r. And you can get each of these identities by dividing both sides by one of the terms. Okay, so when you see a squared trig function, think, is it possible for me to simplify and replace that with some sort of Pythagorean identity? So that's one thing to look out for. The second thing is sometimes a great strategy is to rewrite everything in terms of sine and cosine. So rewrite in terms of sine and cosine. So let me give you kind of 2 basic examples. And so one thing you might think of, this would come up when you're using reciprocal identities. Like if I have cosecant theta, I can replace that with 1 over sine theta. Or also the quotient identities. So don't forget those. The quotient identities are tan theta is sine over cosine, and cotangent is cosine over sine. So if you don't see anything squared, you may think, okay, maybe let me rewrite things in terms of sine and cosine, and maybe that will be helpful. So one example would be, again, these are somewhat simplistic, but if I had cosine theta secant theta minus 1, looking at that, all right, I'm not going to use a Pythagorean identity, but secant is 1 over cosine, so maybe I could do that. And when I distribute the cosine, I would just get 1 minus cosine theta. Or another example would be, say I see in a particular problem, I've got cosine theta times tan theta. Again, let's think, okay, tan theta, can I rewrite that in terms of sine and cosine? Well, tangent is just sine over cosine, that quotient identity. And yes, this makes it much simpler to just sine theta. Okay, so squared trig function, Pythagorean identity. Maybe it's a good strategy to rewrite things in terms of sine and cosine. Another strategy sometimes is, if you have more than one term, is to make a common denominator. One fraction can be more simpler than 2 separate fractions, so make a common denominator. So let's think about a problem there. So in my tutorial, I thought of this problem, which ended up working out quite nicely, miraculously. 1 over 1 minus sine theta plus 1 over 1 plus sine theta. Okay, so right now, nothing squared, so I'm not going to do Pythagorean identity. I already have sine, so I'm not going to do a quotient identity. So my thought is, okay, let's make it just one fraction instead of 2 separate fractions or 2 separate terms. The common denominator are just these two things multiplied times each other. So 1 minus sine theta times 1 plus sine theta, which means to get that common denominator, I'm going to multiply the first fraction by 1 minus 1 plus sine theta over 1 plus sine theta, and the second one will be multiplied by 1 minus sine theta in order to get that common denominator. Well, this means my numerator is going to become 1 plus sine theta plus 1 minus sine theta. All right, so looking at that, simplifying the numerator, I noticed something nice, that the signs go away. So I've just got 2 in the numerator. And the nice thing about this denominator is it's a difference of squares. So if I'm foiling it out, these middle terms are canceling, the positive sine theta and the negative sine theta. So I'm just left with, again, 2 is in the numerator, and I'm left with 1 minus sine squared theta. And as we mentioned above, you know, bells should go off here when, oh, I've got something squared. Let's go back to my Pythagorean identities. And is 1 minus sine squared equal to something? And if I rearrange this Pythagorean identity, and it indeed is, it's equal to cosine squared. So I've got 2 over cosine squared theta. And still a fraction, so can this be made simpler? Well, I can think of this as 2 times 1 over cosine squared theta. And we know 1 over cosine squared theta is just secant squared theta. So that one works out quite nicely. So sometimes more than one term, try making a common denominator. If it doesn't look like anything else is going to happen for you. Okay, the last thing, and which is super important that people tend to overlook, is to, when you, again, talking about having multiple terms, see if there's a common term that you can factor out. Is there a GCF? So factor out a common term. Okay, so let me give you an example of when this might occur. So if I had something like sine squared x plus tan squared x sine squared x, and I think something similar was on the formative quiz. So people, the first instinct for people here, which isn't a bad one, is to change tangent squared to sine squared x over cosine squared x using that Pythagorean identity, which is a good strategy, except for the fact that that's not going to help us out here. I mean, it would be nice if it was cotangent squared x, because then this would flip and the sine squared would cancel. But in this case, I'm just going to get sine to the 4th x, so not super helpful. So, but that's good to see. You know, you go down a strategy and realize, okay, that's not making things simpler. So then I invite you to think about, I've got 2 terms. They do have something in common. They have this sine squared x in common. So what about if I factor that out, like I would any sort of GCF and other algebraic problems? So when I factor out sine squared, I get 1 plus tangent squared x. And again, hopefully somewhere on the side, you've got these Pythagorean identities, and you'll see, let's go back up to the top, that 1 plus tangent squared is equal to secant squared, which is fabulous. So now I can replace 1 plus tangent squared with secant squared x. Okay, I'm still not satisfied here. What can I do with secant squared? Well, I can change it to 1 over cosine squared x. So now I've got sine squared x over cosine squared x. And remember what that really means, that little superscript of 2. This just means I'm taking the sine of an angle and the cosine of an angle and getting a ratio and just squaring it. So we know sine over cosine is tangent, so this is just the same as tangent squared x. Okay, so hopefully that's helpful. Again, the strategies, If I have something squared, would a Pythagorean identity make things easier? Can I write things in terms of sine and cosine? Would that make things easier? If I have more than one term, would it be helpful to find a common denominator? And finally, again, if I have more than one term, is there something in common in both terms that I can factor out? So I hope that's helpful, that those are some really good strategies for what we've done so far with identities. More to come when we introduce more identities, but this is a good start.